Okay, the plan here is that we are using the Typhoon HIL framework to show you how we can send analog signals to the three-phase voltages and three-phase currents of one PMU, and then this PMU will send the data streaming using digital Ethernet. So let's start this demonstration in a very simple way. Here we have the Typhoon HIL control center, and because I need to use the real device, I will use the device manager in order to establish the connection with this very interesting Typhoon HIL 604. And as you can see right now, I have a connection with the real device. So from there, what I'm planning to do is I will use this very interesting system. This is a system that we are preparing. We are calculating the RMS value of a three-phase voltage, and over here a three-phase voltage is used to create the equivalent current signals. And what is extremely important is that we are sending the three-phase voltages to the terminal of the modular HIL Connect interface using the terminal 21, and also three-phase current to the terminal H17 of the HIL Connect. Well, right now I explained this schematic, and what I will do straight away is to compile this model and send this model to the schematic, HIL schematic. Right now we are compiling and is loading the model into the HIL 604, and right now we are ready to open the panel. As you can see over here, this is a very customized panel that I can send voltages and currents into the Phasor Measurement Unit. In this case, the Phasor Measurement Unit is coming from the manufacturer Arbiter, and this is the 1133A. This is the model of the PMU. What I will do now is I am sending right now, I start the real-time simulation. You can see that right now the voltage is 0 because I need to select here a voltage. Let's go for 25 volt here, and let's say a current of 2 amps. Remember, no, let's say 0.5, okay? 0.5. 0.5. And right now we have here 0.5, okay? You can see that this is the time domain representation of the three-phase voltages, and over here you have the RMS value, 25 volts and 0.5 amps, okay? The HIL Connect is applying those signals to the Arbiter 1133A. What I will do now is I will open the software of the Arbiter 1133A. In this case, the software is coming from all colleagues from Arbiter, and this is the PSCSV. And the first step is I need to establish the connection using the local area network and using the TCP IP protocol. As you can see, there is already here a connection already established for the IP address 192.168.1.252. And what I will do is establish the connection, okay? You can see here that the connection is already established, and what I will do now is I will use this Power Sentinel software in order to show you the the phasors, the phasor measurements. Okay, what I will do now is I will connect here, and right now you can see in front of you, the phasor measurement units. You can see that the voltage A, B, and C, there is a value that is around 25 volts. You can see the phase angle for A, B, and C, but also the currents. It's quite interesting that you can see 0.495. That is the current A, B, and C. In this case, the frequency, you can see that the frequency is almost 50 hertz. You can see that the variability is very, very small because we are using, in this case, we are using the HIL Connect to send those signals to the Arbiter. Okay, what I will do now is one of my most interesting tests. What I will do is right now, let me reduce the size of this and put to one side. And one of the interesting question is what's happen if we reduce the frequency. Okay, right now I will use 49 hertz, and when I use 49 hertz, you can see how the phasors start to rotate. However, 49.0 probably is too low frequency. Let me use 0.99, and now you can see how the phasors are rotating, but very, very slowly. Okay, in this case, it's rotating at the same direction. It's a clockwise direction. But now let me increase the frequency. Let me use 50.01, and now the phasors will start to rotate on the other direction, and I believe every single one of you can see how the phasors are rotating on the other direction. Of course, you can see the same here. The frequency is going to 50.01, and you can see here the phasors, and right now you can see the rotation that is anti-clockwise. Okay, well, with this demonstration, I am extremely happy that I showed you how to see the phasor measurements using the software from Arbiter system, and I am using the modeling and simulation framework from Typhoon HIL to show you those phasor measurement units. Well, thank you for watching this video, and I will see you at the next one. Bye now.